You finish your treatments, you beat the cancer, but for many survivors, the victory is immediately followed by a thick, disorienting mental fog. Patients experience a severe and persistent decline in memory, learning, and focus, a haze that can linger for months or even years after the treatment ends. Doctors have known for a long time that systemic chemotherapy correlates with these cognitive deficits, but finding the exact biological trigger inside the brain has been incredibly difficult. The problem is that human cancer patients have a lot going on. When memory starts to fail, researchers struggle to determine if it's caused by the physical presence of the tumor, the immense stress of the disease, or the chemical drug itself. To solve this, scientists realized they had to shift their focus. They stopped looking at the brain's neurons and started investigating its hidden plumbing system. Tucked inside the dura mater, the tough outermost layer of the brain, is an intricate network called the meningeal lymphatics. These vessels act as the brain's primary physical waste clearance system. They flush out cerebrospinal fluid, dead cells, and immune signals. This fluid flows smoothly out of the central nervous system, draining downward through the skull and emptying into the cervical lymph nodes in the neck. If this drainage route is damaged or blocked, the brain's environment becomes compromised, toxic cellular waste backs up, and the whole system stagnates. To see exactly how chemotherapy affects this plumbing, researchers built a multi-layered testing ground. They examined human cells in a lab, isolated mouse tissue, and eventually live mice. By using tumor-free models, they stripped away all those confounding variables. They could watch how the physical drainage system reacts to chemotherapy, completely isolated from cancer itself. The primary suspect emerging from these tests is a highly common taxane-based chemotherapy drug called Docetaxel. They compared it against carboplatin, a platinum-based chemotherapy. The results proved that not all systemic chemotherapies behave the same way or cause the same collateral damage in the brain. While the platinum-based treatment left the lymphatic plumbing relatively intact, Docetaxel triggered a catastrophic structural breakdown. This image shows docetaxel-treated cell cultures on the right, compared to an intact vehicle group on the left. The cells forming the lymphatic vessels clump together into abnormal, disorganized plaques. Moving to the tissue level, these images show the macroscopic damage. The treated lymphatic vessels lose their vital branches and structural loops, which are critical for transporting fluid. These MRI velocity magnitude maps show the immediate consequence of that damage. The areas treated with docetaxel show a clear reduction in fluid flow velocity across the brain. Docetaxel is giving something structural. It is physically ravaging the brain's waste infrastructure, causing critical fluid to slow down and stagnate. The physical plumbing was definitely broken, but researchers still had to prove that this fluid stagnation actually causes memory loss. In a novel object recognition test, mice are familiarized with two identical objects. Later, one is swapped. Healthy mice prefer the new object, but docetaxel-treated mice completely lost the ability to distinguish them, demonstrating a severe memory deficit. We see the exact same biological mirror in human patients. The structural damage in the brain's lymphatic system perfectly aligns with documented memory deficits of Chemobrain. Chemobrain is a tangible, physical condition. It is the direct result of structural injury to the brain's waste clearance network. It presents a cruel irony in modern medicine. By aggressively attacking cancer with certain life-saving drugs, we inadvertently break the very drainage system the brain requires to heal. For medical teams today, this means implementing strict cognitive monitoring for patients, specifically undergoing taxane-based regimens like docetaxel. Looking forward, this discovery paves the way for concurrent therapies. We can now start designing treatments specifically meant to protect or regenerate these meningeal lymphatic vessels while the chemotherapy does its job. Because the ultimate goal of medicine extends beyond curing the disease. It is to ensure that when a patient survives cancer, their mind, their memory, and their future survive fully intact.